Today we're going to start a new transformation. This one is called a translation, and you can use the date of May 26th. Your note packet should have 4 pages, and this is what they look like. You'll also want to find a ruler or a straight edge so that we can work on this packet. All right, let's start with the definition of a translation. Basically, what you're doing is taking every point on the figure, and everyone is going to slide the same distance and the same direction. And that's what it looks like in the coordinate plane. It looks like you took the original pre-image and you slid it to a new location. So we sometimes nickname a translation a slide. We have 2 different abbreviations. The easiest one is to use capital T for translation. And then in subscript, you're going to give the movement of the figure. Don't put parentheses around this ordered pair because it's not really an ordered pair. So 3 is positive. This is the direction you move on the x-axis. 4 is positive. This is the direction you move on the y-axis. If you studied these transformations in grade 8, you might have seen abbreviation number 2. We take whatever point we're provided generically at x, y, and it maps itself. In this case, we're saying add 3 to x and add 4 to y. And really, that's what we're doing when we come up with our new ordered pairs. We're adding and subtracting to find its new location. So to build onto that, this is how you're going to translate your figure. Whatever value x takes, if they ask you to add or you see a positive value in the rule, you're going to move it that many units right. If you see a negative number sitting in that translation rule or looks like subtraction, we're moving that many units to the left. Once you've moved your x coordinate, now we need to move the y coordinate. Same idea. If they ask you to add some amount or you see a positive number in the rule, we're sliding the figure up that many units. And same thing, if they ask you to subtract or you see a negative number in the rule, you're going to move the value down that number of units. So up and to the right are positive moves, down and to the left are negative moves. And it really follows the normal idea of the coordinate plane. In example number 1, they're giving us 3 points, HAM, triangle ham. They want us to translate it using the rule -5, -4. So this would mean I would move it 5 units to the left and then 4 units down with the -4. We're going to start by graphing triangle ham. And we want to make sure we also label the vertices. When you do a full mapping, remember we list the 3 original points. We place the arrows to show mapping, and we put the rule above the arrows. So 5 units left and 4 units down. I'm going to actually subtract. So according to H, it's 3 minus 5, and then -1 minus 4. So that should be -2, -5. We're going to use the same rule on all the points. They all move the same distance and in the same direction. -1 minus 5 will be -6, and 1 minus 4 is -3. And then for M prime, -1 minus 5 is -6, and 4 minus 4 is 0. Now that I know the location of triangle H prime, M prime, and A prime, I'm going to go ahead and graph that. And you can see that it's exactly the same shape and exactly the same size. We just slid it to the left and down. For example number 2, we have quadrilateral mope. We're going to start by graphing mope. So it looks like a trapezoid. I've got all my vertices labeled. We're going to translate it using the rule 4 and -6. So we're going to go 4 to the right, 6 down. When I apply this to my ordered pairs, I've got my original points listed. I'm going to set up my mapping and my rule. And again, it's going to be -4 plus 4 and 6 minus 6. So it looks like M prime is going to be at 0, 0. So for O prime, we're going to add 4 to X, subtract 6 from Y. We'll do the same with P. So -2 plus 4 and 3 minus 6. And finally, -4 plus 4 and 3 minus 6. And again, I know the new location, so I'm going to go ahead and graph. And there is quadrilateral MOP prime. We went 4 right and 6 down. Translations are pretty easy. It's probably one of the simplest rules. So for this example, number 3, it says that the use of the grid is optional. So whenever I know the rule really well, I usually choose to not do the grid at all. So I'm going to take triangle RST. Now we have 2 rules here. The first rule says take triangle RST, and we're going to translate it 0, 5 to create R prime, S prime, T prime. Then, according to the next step, it says to take triangle R prime, S prime, T prime, and translate it again with a new rule to create R double prime, S double prime, and T double prime. So remember from our last assignment, we want to just build off of what we're creating. So let's set up our 3 original points, and I'm going to put the first rule there. So I'm adding nothing to X, and I'm adding 5 to Y. So there's R prime, S prime, and T prime. Now, to apply the second rule, it says to use what you just created. So I'm going to just keep building. I'm going to place my new rule. And then we're going to subtract 1 from X and subtract 2 from Y. So R double prime, let's see, S double prime, and T double prime. So we did a complete mapping without having to graph anything. Now, instead of graphing it and coming up with the new locations, let's see if we can write the rule for the translation that's occurring. So in the first example, B ended up at 4, 6. So we want to identify what happened between -2 to get us to 4. Think of the number line or the x-axis, and I had to add 6 to get there. Same thing with the second part, 10 turned into a 6. This is along the y-axis, and it appears that I subtracted 4. I'm going to use the newer translation rule with the capital T. So add 6 to X, subtract 4 from Y. In our next example, we still ended up at 4, 6, but we started in a different location. So to go from 0 to 4, we're going to add 4. And then from -7 to +6. Thinking of the y-axis, I'm way down low at -7. I had to rise 7 units to get to 0, and then 6 more. So that's 13. And that should actually be +13. We're going to fix that right now. +13. All right, for our next example, we went from 3 to 4, and then from 0 to 6. I'm going to use the different rule style. So I'm adding 1 to X, and I'm adding 6 to Y. In our last example, looks like I'm adding nothing to X, and I'm adding 1 to Y. You can put +0. Other students will just do X without the +0, and then they'll do comma, Y plus 1. Either method is acceptable. Let's write the rule for this figure here. You only need to focus on one point on the original figure, which is here in quadrant 2. So if we focus on A, we're moving 1, 2, 3, 4, 5, 6 to the right, so that's +6. And then we have to drop 3, and 1 more is 4, so -4. So our translation rule is 6 right, 4 down. In the second example, again, you can just pick one vertice to focus on. If I focus on G, I have to move 1, 2, 3 to the left. Moving to the left is -3, and then I'm going to move down 2, 3, 4, 5, 6. So -3, -6, and there's my translation rule, left and down. So under properties, what we notice most with translations is that under a translation, a figure and its image will be congruent. They were even facing the same direction. So a translation is classified as an isometry, which is a rigid motion. We preserve distance between points. This is homework number 126. It's a two-sided paper. For the first page, you don't have to write full mappings. You can just tell me where the point goes or where it's going to end up. But on the second page, 28 and 29, make sure you do a complete mapping with original points and rules, and then you're building on. If you have any questions, make sure you get in touch with me and I'll help you out. Have a great day.